Hello and welcome to another CS Tutor Center video. Today we're going to talk about the problem permutation in string. But before we get started, please let me know if you'd like me to make more of these videos by subscribing to this channel. When you subscribe to the channel, it lets me know that you're enjoying these videos, and as a result, I'll go ahead and make more of them. So let's get started. Given two strings S1 and S2, return true if S2 contains a permutation of S1, or false otherwise. In other words, return true if one of S1's permutations is the substring of S2. So what this is saying is that we have this string S1, and we want to see if any permutation of this string exists inside of the S2 string. And we can see that it is right there. There's a permutation. And so as a result, this is true. Next, we come down to this string here, and we see that there is no permutation of this string inside of S2. There are the same characters. There's A and there's B, but there's an extra character, which is O. So this is not a permutation, and as a result, it's false. Okay, so we want to think about the different kind of coding patterns we can use to solve this problem. Well, one coding pattern that would be great for this is the sliding window. And the reason why is because when we look at this string, we could create a window that is the same size as that string. And then we could just slide it across S2, asking ourselves if the letters that we need to find exist inside that window. So for example, we look at this problem, and we could create a window, and we'll grow it to be the size of this string, and then we'll see if these characters exist inside of the window. And if they don't, then we'll slide, and we see a D entered the window and an E left, and we still don't have that scenario. Then we see a E or a I left the window and a B entered, and we still don't have this scenario. And so then we slide it again, and a D left, and an A entered the window. And now we have this scenario where we have the same number of characters and the same counts of those characters inside of our S1 string, and so this is true. And as we see, we're sliding left to right, and we're revealing a new character each time we're sliding. In the worst case scenario, we're going to end up sliding across this whole array. And we're only going to have to go over the array once. And if we only have to go over the array once, then that's linear. And we know we can't do any better than linear, because if we were to look at an array, when they give us an array, we have to reveal all those question marks in order to know whether or not that there's a permutation inside of this array. So we have to look at each one of these in order to know, because if I stopped here, maybe there's a B right there. And I know that if you give me an array of size n, and I have to iterate over this array of size n, then I can't do any better than linear. So if we find a coding pattern that we can use to solve this problem in linear time, and we know we can't do any better than linear, then we have a coding pattern we can use to solve this problem. It checks out with the big O that we need to accomplish. All right, so let's look at the constraints. The first constraint says that s1.length and s2.length are between 1 to 10 to the 4 inclusive. So there could be a scenario where the S1 string is larger than the S2 string. And if that ever occurred, then we just return false right away, because you can't have a permutation of S1 inside of S2 if S2 is smaller than S1. So next, the other constraint says S1 and S2 consist of lowercase English letters. Okay, in our algorithm, we have a choice. We could use an array to keep track of the counts of these letters, or we can use a HashMap to keep track of the counts of these letters. Because this constraint says you can use English letters, or sorry, because this constraint says that the strings are only going to be English letters and they're lowercase, you know your array can be size 26, and then you can just go ahead and use an array. If there was no constraint on what the letters could be, you'd use a hash map because you wouldn't know how big this thing can be. So the reason why it's better to use an array is because it's going to be a little bit faster than a hash map. Both the hash map and the array are constant big O time to read from and write to. But in a real world running scenario, when you run your code in real world, it's gonna run a little bit faster to use an array. And the reason why is because whenever you read from a hash map, it calculates using a hash function. It calculates the index to use to find what you're trying to read, or where you want, or when you write, where that should get written to. Okay. Because remember, in a hash map, it's just there's an array internally, and you need to know the index to use to access that array, and there's a hash function inside of the hash map that will calculate that for you. So a little bit faster if you use an array. In all my other sliding window problems where we have this constraint, I use an array when the scenario presents itself because it's better to do that. I want to show you what it would look like if I just used a hash map. Okay, and you could rewrite this using an array. And maybe I'll make another video. If you subscribe and let me know that you'd like me to make another video, I'll do it with the array too, and then you can see both scenarios. Okay, so let's look at this. Let's look at this code. So what I'm going to do first is talk about, before we get into the code, I'm going to talk about the concept of how we'll solve it. All right, so we'll start with this window, which is just pointing at location 0 here. And actually, before we even work with our sliding window, what we're going to do is we're going to build our hash map. So we're going to loop over S1, and we will increase the counts of the letters that we have inside of this S1 string. So we have 1A and 1B that exist. Okay, now what we'll do is we're going to do our sliding window algorithm. So we see that there's no E inside of this, and this, there's 2 letters here, right? So we're going to grow this window. There's no I inside of this. Okay, so we'll go like that. So E left the window, D entered the window, there's no D in here. Slide over here, B entered the window, I left the window. B entered the window, there is a B, so we decrement. Okay, because we hit a 0 here, that means we matched one of our unique letters. So we increase our matched count. When this match count ends up being the size of this map, that means that we've matched all the letters. Because we could have, like, what if we had this, right? Then we need to, the reason why we have these counts is because we know we need to have 2 B's and 1 A inside of a window. And so as a B enters the window, we decrement. And then as another B enters the window, we decrement. And then once we hit that 0, we know we matched one of the letters. Okay, so that's why the match count. All right, so the B entered the window, so we decrement the B, hit 0, so we increase the match count. We slide, D left the window, A entered the window, A is in our map here, so we decrement that. That just hit 0, so we increment our matched count. And now, as a result, our matched is 0, or sorry, I meant to increment. We increment our match count. As a result, our matched is 2, which is the size of this map. The size of a map is a number of keys that are in it. So we have 1A and 1B, so that's 2 keys. So our the size of the map matches the matched. So that means we found our answer and we return true. Okay, so that's it for the example 1. Now we got to think about when are we ever going to need to shrink the window? We never need to shrink the window because, well, I guess technically in our code we will shrink the window because by every loop we will increase by 1. So our code will kind of look like this. It will increase and then it will decrease like that. Increase and then decrease. So if it's ever the case that this window is larger than this S1, then that's when we would shrink. And that's the only scenario. So when we have our window end, it's going to start out 0, and our window start is going to start out 0. That would put us right over here. And then we increase that, so then the window end goes to here. And then on the next iteration, we increase this, and the window end goes to here. Okay, so here's our index is for the S1. So when our window end is greater than or equal to our S1 dot length minus 1. So our S1 dot length is 2. Minus 1 would be 1. So that's our index. So when this window end ends up being greater than or equal to 1, that's when we would shrink by 1. Because that would just say, oh, we came into a scenario where the window is 1 larger than our string, and we don't need it to be 1 larger than our string. Okay. Okay, so let's look at the code. Let's start writing it. So first off, we're going to do that first check where we see if s1.length is greater than s2.length. And if that's the case, we'll just return false because there's no sense in even trying to do the sliding window. Imagine these are both 10 to the 4, then, or sorry, imagine this is 10 to the 4 and this is just 1 less than that. Well, we could just return right away and that would save some computing time. Our algorithm's still going to be big O of n because we go by the worst case when we figure out big O of n, and our sliding window is big O of n. But if you can if you can just add this if check, and it makes it just a little bit faster and also kind of makes the code a little more obvious, then that's a good thing to do. All right, so then we'll make our map. So we'll have this map. It's going to keep track of our frequency counts of our S1. And then we'll say frequency map.put. All right, so I'm just going to say here, loop over all the characters inside of this S1 and put it into this map. And the value of it, well, what I'm going to do is I'm going to get from my map, I'm going to go look up what the existing value of it is. If it's not in the map yet, then give me a 0. If it is in the map, then give me the value. And then I'll add to that 1 to increment. All right, so then next we're going to have our match count. And then we'll go ahead and loop. Uh, ah. All right, so let's have our end char here. Okay, so we're going to have s2.char at window end. Okay, and now, so we have the character from our S1, and then now what we're going to do is we'll go ahead and check to see if that is inside of our map. All right, if that is inside of our map, then what we're going to do is we're going to go ahead and decrement. So let's go like right here. So when we slit it like this, then we saw that, oh, B is inside of our map. So because B is inside of our map, let's say we had this initially, right? Oh, B is inside of our map, so we need to go decrement this. And if we decrement that and it hits 0, then we need to increment this. Matched. So let's do that. So decrement from the map, and then if the map with that value is 0, then we need to increment our matched count. And then at that point, if the matched count ends up equaling the size of the map, then we know we found our answer. Okay. All right. Okay, and then so let me back up here. Let me go all the way to this scenario. We're right here. We're checking to see if that match count is there. It's not. So then we'll increase on the next loop. Check to see if the match. Sorry, I said match count, but check to see if the E is inside of this. And let me like reset all this up real quick for you. Okay, check to see if this E is inside of this hash map. It's not, so we loop again, increment. So this got incremented just now. Check to see if the I is inside of there, and it's not. So then now we're going to end up doing this. We're going to end up shrinking the window because on the next loop we're going to increment. And then it's going to just kind of look like this. So now we just hit this B that we just coded up, right? Where this got decremented, that hit 0, so we increase the match count. And it's not matched yet. 1 does not equal size 2 of this map. So we need to decrement this. Remember that always decrements. So if it ends up being that the window end is greater than or equal to the s1.length minus 1. Okay, so we have that. We have this character. Oh yeah, sorry, that's not it. We use our Windows Start. So we use our Windows Start to read from our S2 actually. Sorry about that. We use our Windows Start to read from our S2 string, and then after we read from it, then we're going to increment our Windows Start to go to the next one. So here we are. So we are currently here. We read this D from there, and then we increment our Windows Start. So now we have this D, And then we need to go see if we need to, since that left the window, if we need to change our hash map. So let me show you this scenario where we are. Let's pretend that there was a B in here, so I can show this. Just there we go. Okay, if there was a B in there, then we would have, let me go back over here, and this is 0, and let's say we were like right here, and okay, so I'm setting us up where we are at the start of this loop here, we're coming in, and and we check to see if the I is there, and it's not, go like this, and now we're on the next loop, okay? So we're on the next loop, we just entered in, and we just entered in, so the B gets decremented to 0. That match count happens, and then what we're going to do is we're going to subtract off. We're gonna move this up here, okay, and then this grows, and that B entered, so that would be, now there's 2 B's on this loop where we are in here, and we say, oh, it does contain it, so we'll decrement 1. So we decrement, so now this goes negative. And then we see that window end is 3. And 3 is greater than the window length minus 1. Window length minus 1 is 1, so 3 is greater than 1. So we know we need to shrink the window. Okay, now when we shrink this window, the B left the window, so we need to reflect that by adding 1 inside of here. This keeps track of, you know, how many letters we have left in the window. So we don't need any more B's currently now, since we updated that. That tells us that. So what we're going to do is we're going to write the code down here to do what we just did there, where, let me back up again here. We were here, we had a scenario where the map says we have 2 B's in here. We are going to shrink the window. We shrink it. So we read that B out. So we read the B here. It's in the start char. Now we got to go update this map to reflect that that B just left the window. So we'll do that. Okay, so we say, is it in the map? And if it is in the map, then let's see if it is, if the value is currently 0, because if it is currently 0 and we're going to put it back in there, that means that we need to also reduce our matched by 1. Okay, great. All right, now if we get all the way down to this for loop, then we are in a situation where we never found the solution, so we return false. This is the situation where we found the solution. So let's run this. Okay, shoot. I missed something small. All right, let me come back over here real quick. Let me see, let's review our code real quick to see what we missed here. So we have S1 is greater than S2, return false. We incremented our frequency map. We have our match. We go from 0 down there. We get our nchar here. We have our frequency map where we're going to check to see if the nchar is in it. If it is in it, then we're going to decrement by 1. We'll check to see if it's 0. So matched equals that. Then, oh, why did I say? This should be true. Duh. Okay, so I meant to say true. So if this gets matched, then that's true, and we, that's the solution. Otherwise, we're gonna check the window size. We read the start. We check to see if that start char is inside of our map. If it is, check to see if it's 0. If it is, decrement by 1, and then update our map to increment that. And if we come all the way down to here, then we are in a situation where it's false. Okay, so great. Now we will run this. So accepted, and then we'll submit it. All right, and that passed. So let's look at the Python version now. Python's it's the same. I kept the style as close as possible code-wise, just using the Python syntax. So here you can see the code for the Python. All right, so I'm going to run this. And then I'll submit it. Okay, great. So let me highlight some things. You see it says beats 80% with Python, and if we go to Java and we run it, and then it says beats 36% of users with Java. So why is that? Well, remember I was saying that if you use the array, and this is why I want to use the hash map in this particular one just to highlight this, and because all the other ones I use the array when we can. If you use the hash map uses the hash function to calculate the index. So even though the big O is constant on the lookup of the hash map, the real world time complexity, it's going to be a little bit faster to use an array instead, because you don't have to calculate, you don't have to use the hash function to calculate anything. With an array, you're providing the index, and so it's a direct lookup. And so if you swap out the hash map here by using the array, it's going to be a whole lot faster on Leetcode when it runs against the other submissions. But the big O time complexity is still linear, because we're going with our worst case scenario, right? And the hash map versus the array is constant, but it's just the real world runtime of the array is faster. Okay, anyway, so if you liked this video, please go ahead and like it. If you want me to make more of these videos, please go ahead and subscribe to the channel to let me know. And have a good day, and I'll talk to you guys later.